All right. We just gotta hold on a little bit longer. Don't worry about it. Anyway, so let's see what we're doing today. So solve quadratic equations using completing the square method. All right, so let's see, completing the square. I'm not sure if we've ever done that before, but just a quick recap, we've also used factoring. So you can solve a quadratic equation by factoring. And basically, again, just a quick recap on what solving a quadratic means. It means that if you were to have a graph, I'm gonna just draw 3 graphs here, and you were to graph those parabolas that are in those graphs, right? You can have 2 solutions where you have 2 contacts with the x-axis. You could have 1, and I'm just going to use a basic parabola here. So we have 1 contact, which would mean there'd be 1 solution. And then there would be no solutions, or sometimes we call that complex solutions. And that's usually what happens when you get an imaginary number in your solution. So when you get an imaginary number in the solution, it's, well, it's kind of like a solution, but not really, because if you were to lower this parabola, it would contact it. So there is a point when it can happen, but it's just not something we generally use. But again, I'd like to explain a little bit more, but I wouldn't want things to get overly confusing. So anyway, let's go ahead and solve quadratic with perfect square trinomials. So solve the equations below by using factoring and the square root property. Okay, that was the other one we covered, was the square root property. So let's see, factoring and square root property. So let's look at this one here, and remember the recap on how you do this is the first thing you would do is you would, well, hold on. We could factor this kind of here, right? You could use the Loif method, and in that case, it looks like we already have one that is a perfect square trinomial. And it's a perfect square trinomial, and it says right here in the directions, and that's kind of giving me the hint on what to do. Because normally I probably -4 from both sides and try from there. But in this case, they left 4 purposefully on this side. So now we're just going to factor this area here, and that's going to cause us to go with the Loif method. So last number, 2 numbers that multiply to 49. Okay, 7 times 7. And we need that to multiply to positive 49. And remember, there's 2 ways to get a positive. Positive times positive is a positive. Or actually, in the other way, it would be a negative times another negative would also be positive. A positive times a negative is the only way you can get a negative. So in this case, remember, this means that they will be the same, and they will be the same as whatever the first one is, which in this case, it is positive. So that means that these 2 numbers multiply to 49, but will add, so 7 plus 7 is 14. So there you go, it's working out. And then I'm gonna get x here. So that's the first thing, the first number is the last thing we do. And then we still have 4 on this side. So what do we do with all of this? All right, so the thing about a perfect square trinomial is that you can also simplify it when writing it as that group squared. So I'm going to put these 2 together because that's what it means. X plus 7, x plus 7. And if x plus 7 squared exactly means these 2 things. You're multiplying those 2 groups together. Now, what's going to happen here is we are going to take the square root of both sides. So I'm going to take the square root of this and the square root of this. And what's going to happen with that is on this side, the square root and the square cancel each other out, right? Because they're inverse operations. So being inverse operations, they are like the opposites and they cancel each other out. So now it is no longer under the radical and it is no longer squared because both of them have done away with each other. Now, anytime you take the square of something on the other side, you have to consider 2 possibilities. The the positive or the plus and the negative or the minus. So you put this plus and minus sign here to show that there's two possibilities. Now, this is also a little bit confusing because we're gonna have, normally I think we'd kind of stop there. I'm trying to remember what we did the last time, but if I were going to minus 7 from both sides, we'd have to consider two possibilities. X equals, because now we got rid of this 7 here, and first possibility is 4 minus 7. And there is a second possibility where now we consider the negative 4, so negative 4 minus 7. So the first solution is 4 minus 7, which in that case would be negative 4 minus 7. Oh, you know what? I did not take the square of this number here. Sorry, the square root of this number. It should have been 2 because we took the square root of it. So that would mean that this would be 2 and that would be 2 as well. All right, ooh, off to a bad start today. 2 minus 7, so this would be actually something different. It would be x equals negative 5. And I'm gonna go ahead and put them into a set notation because now we have two solutions, negative 2 and negative 7. So this would be negative 9. And I'm gonna go ahead and put those parentheses, bracket things here, braces, to show that those are the two solutions. Actually, I think this one's supposed to go here. But anyway, yeah, negative 5 and negative 9 are the two solutions that we would have. So if we were graphing this, we're done with this problem. We don't need to do anything else with this one. If we were to go to negative 5 and negative 9, our parabola would probably look something like this. It would cross at negative 5 and negative 9 here. Okay, so let's go ahead and do the same thing on this side. So I'm going to go ahead and break this down in the perfect square trinomial. Now, let's check to see if this will work. And you can also use that take it, half it, square it to see if this is what you need. So if you remember that, you can go ahead and use that. So that'd be like negative 3 and then square it. And that would be negative 3 times negative 3, which is 9. So this is a perfect square trinomial. And I know that was a while back, so if you don't remember that, that's okay. So we need two numbers that multiply to 9. Okay, so 3 and 3. Now again, this tells us not what the signs are, it tells us they are the same. And when they are the same, they could both be negative, which is the case here, because this one is a negative. And if we quickly review the FOIL method, negative 3 times negative 3 is positive 9. And negative 3 minus 3 is negative 6. So there you go. It works. We checked it. Let's go ahead and drop the x there. And we haven't done anything with this here. So I am also going to rewrite this so that we have a square. And take the root of both numbers. So x minus 3 equals, and then I have the square root of 20 here, which it does not break down nicely. So let's go ahead and take the square root of 20, right? Now I'm going to break it down. And we want to break it down into two numbers that have a square in it. So 4 times 5 is probably what we need to go with. Now we can take the square root of 4, which is 2, and we cannot do anything with 5 because there are no other factors with 5. 1 and 5 are the only ones we have, so we're going to leave it in there. We're going to leave it underneath the radical. All right, now in this case here, we still have to get rid of this minus 3, so I'm going to add 3 to both sides. Now by adding 3 to both sides, this is kind of a weird case because, well, we can't put these together because they are not like terms. This is kind of like a variable. Just a quick recap also. If I would just example, let me go ahead and put an example over here. If I had like 2 times root 2 plus 3 root 2 plus 6 root 3, you treat these roots like they're variables, right? So in this case here, I have two numbers that are root 2. I can put those together, but I cannot combine it with these here. Now, this is a regular number with our 3 here, and then we have this irrational number. So they're not the same. We can't put them together. So what we're going to do is, well, we don't need the plus and the minus here because we can put 3 plus and minus, oops, almost forgot the 2. There we go, something like that. So 3 plus and minus, because we got to consider the plus and the minus possibilities, 2 times the square root of 5. Now in this case, there is nothing else we can do. There is nothing else we can do. We cannot simplify that anymore. And I mean, we could get a calculator and divide it out and all that stuff, but we don't really need the decimals. All right, so those are the two cases of solving quadratics with perfect square trinomials. Let's go ahead and move on to what we need to know for this lesson, and that is how to use completing the square. So it's going to be the same thing, just a few more steps. It is possible to take any quadratic equation, create a perfect square trinomial, and solve it in a similar way. This method is called completing the square. So we're trying to make what we have here look like what we just got done doing. So that's the step that we're going to have to do, is make it look like this so we can use completing the square, because completing the square requires a little bit of setup. So the first thing we got to do is rewrite it in standard form. Right, so we got to make it look like this. So descending powers of x, but c is going to be by itself. Divide both sides by a so that we get x squared plus bx equals c. So in other words, we got to get rid of this a value. So completing the square, you take b, take it, half it, square it, and add it to both sides of the equation. All right, so again, this is a it seems pretty complicated. I don't know, I mean, I think once you get it, it makes a lot of sense. Just like anything you do, anything you learn, once you learn it, it's not so tough. Factor the perfect square trinomial, take the square root of both sides, and remember to have both cases of a positive and a negative value, because square root can be positive or negative. Solve both equations and simplify all irrational or complex answers. So I guess another really quick one on why we have to consider the positive and negative possibility is because if I have, let's say, I'm going to pick a square number. Let's go with 36. All right, what two numbers can I multiply to get 36? Well, the easiest one is going to be 6 times 6. That's probably going to be the one I'm going to get. But there is another possibility. What about negative 6 times negative 6? So if they were both negative, so if I have negative 6 squared, it would still be 36. So that's why there's two possibilities, because there's the negative, and then here, if I take those off, it would be the positive. So that's why we have to consider the positive and negative possibility. All right, so again, it's a lot of steps. Let's see if we can stick to it as close as we can. So completing the square, solve each quadratic equation by completing the square. All right, so first thing we want to do is, just like it says, let's get rid of this 56 here by minusing 56. X squared minus 18x. Now, as I write this, I am going to leave a space here because I am going to have to fill it in with something. Now, now I remember, we did cover this. We recovered it on converting to vertex form. So we would take things in standard form or in a odd form, and then we would put it into that vertex form. So yes, we did do this. We did do this before. And then we get this number, right? So take it, half it, square it. So I'm going to do this up here. So negative 18. So we take it, half it, we get negative 9. And then from there, we square it. So take it, half it, square it, which in this case, -9 times -9 is 81. So I am going to put in an 81. Now it says whatever you do to one side, you have to do it to the other side. And that's just the universal rule of any equation, all right? Any algebra, any equation, whatever you do to one side, you have to do it to the other side. And you got to be careful because sometimes there are rules when, you might have like an A value or a group. So anyway, let's go ahead and keep going with this one here. Now the reason we did that is because we now have a perfect square trinomial. Now, normally I would do the double bubble thingy here, or maybe I shouldn't skip that step for now. Let's go ahead and do this. Now, sometimes, especially with some of these later ones, I might be running out of space, which is going to require me to have to kind of skip this step here. Anyway, so let's go ahead and do this. So remember this sign, or let's look at the Loif method, last number, means that we have two numbers that will multiply to 81. Now, again, quick tip. It's always going to be this number that you used in your step. So in this case, it's going to be -9. But if you forget that or you're not sure about it, remember, you can always just use the regular Loif method, and that is to look at this. If it's positive, that means they are the same. If it is negative, they will be different. So in this case, they will be the same, and they will both be the same as whatever this is, which again, that's what we got in our B value here, X and X. And now I am going to need, there we go. I'm going to need to know what 81 minus 56 is, and that would be 25. Okay, now I'm going to put these together so that we have only one of them. And now that we have the square, we can easily see that we have to undo that square. So to undo that square number, we're going to take the square root. So x minus 9 is what we get, because now the square is gone and we only have one of it. And we also have to consider the positive and the negative possibility here. And we take the square root of 25, which is going to be 5. Okay, now we got to get rid of this 9. So to get rid of this 9, I'm going to have to add 9 to both sides. X equals 9 plus 5. X equals 9. And then we have to consider the minus. There you go. So 9 minus 5. So let's go ahead and solve this last step, and we should be done with this problem. So 9 plus 5 is 14. And let's see, 9 minus 5 would be 4. Now, actually, personally, I'd prefer to put 4 than 14. You know, I'm going to go ahead and just do it, just because normally we always put things in numerical order whenever we can. So there is usually a certain order to things that we like to put them in. I think if you were to put 4 and 14, I would not mark it wrong or anything like that. I'd probably accept it. But it's just a good habit to get into. All right, so let's go ahead and do this one now. So it looks like it's all ready, right? Because we got to make it look like, well, this, it's already like that. Because our C value might have been like plus 30, but it's already on this side. So we take care of the first step. So first step is to rewrite it so that it looks like this. Second step is to divide both sides by A. So if we look back at the last slide, was to divide both sides by A so that it becomes more closely something like that. And so to divide everything by A means that I'm going to have to divide everything by 2. So divide everything by 2. And in this case, it looks like everything nicely divides because I won't get any fractions. So 2 divided by 2 is 1. 16 divided by 2 is 8. And again, I'm going to leave a little space here because I'm going to need to put in a new number once I know what that number will be, and negative 15. So there we go. Now we have no more A value. I think if there are some fractions, it's not going to be that tough to do. So let's go ahead and do the step number 3, which is once you take you got to complete the square. So we're trying to make a perfect square trinomial by taking b, half it, then square it, and add it to both sides. So take it, half it, square it. So take it, half it, square it. So -8, half of that is -4. Square it, that'd be 16. So we got to add 16 to both sides, because whatever we do to one side, you got to do it to the other side. And like I said, I'm going to kind of skip one of the steps here because I know that it is a perfect square trinomial. So I know that it's going to be x minus 4, because I need two numbers that multiply to 16, which would be -4 times -4, but they would also have to add up to -8, which would mean -4 plus -4 is -8. And like I said, sometimes I'm going to have to kind of shorten this step here. Not really skip it, because this, you would only just see something like this. And here I have 16 minus 15, which would be 1. Okay. Well, I guess that kind of works out, because if I take the root of both numbers, well, 1 is a square number actually. So I'd get x minus 4 equals plus and minus 1. Because the square root of 1 is 1. And 1 is a square number because 1 times 1 is 1. And if I ask you, what two numbers can I multiply to get 1? Well, I can pick two of the same numbers, and that would be 1 and 1 again. So it looks like we still have to solve this by adding 4 to both sides. So let's go ahead and do that. Add 4 here, add 4 here. And let's go ahead and write our two cases out. X equals 4 plus 1, and x equals 4 minus 1. So again, that plus and minus is on the 1, so that's what we're doing. All right, add 1, minus 1. And let's go ahead and get ready to write our answer, because I think we're going to be almost finished with this one. And I'm going to see which one is going to be the lower one. So this would be 5 and 3. So I'm going to put 3 first and then 5, just so I can put it in numerical order. If I had a little bit more space, I'd probably cover that step right there. But again, I'm not going to be too harsh on that. As long as you have the right numbers there, I think it'll be fine. Okay, anyway, there we go. Moving on to the next one. So let's see. Complete the square with this one. So it looks like we have an a value on this one here. And it looks like it's in the right form. You want both x numbers on one side and then the regular number on the other side pretty much by itself. But again, it looks like we're going to have to get rid of this a value. So let's see, x squared and then minus, and then 8 divided by 4 would be 2x. Leave a space. And it looks like we're going to stay with a fraction, because in this case, 3 cannot divide by 4. And I guess you could put something like negative 0.75. Okay, something like that would work out. And I think in this case, I'm going to stick with fractions until I'm pretty sure it would be way more difficult to work with a fraction than just going with a decimal. Anyway, so let's go ahead and get our new c value for this side here. So same rule. Get our b value, take it, half it, square it, which in this case would just be plus 1. So I'm going to have to add 1 here. Okay. And like I was saying, I think it would be, I wanted to stick with fractions for as long as I could. I guess normally I would kind of stick with fractions, but in this case here, I'm kind of running into a bit of a problem here, because I'd have to cover a whole bunch of other stuff in order to do this one. But, let me see if I can do this long story short type thing. 1 minus 3/4. So I'm just going to reverse it so it's a little bit easier to work with. So think of it like $1 and you subtract 3/4. Well, what you want to do is take this first number here, our dollar, and break it into quarters also. So in old-timey machines, you know, they sometimes didn't give you back change and you had to pay in the exact amount. So you oftentimes had to break your dollar into quarters. And any number divided by itself, so in this case, 4 divided by 4 is still equal to 1. So I broke it into 4/4 and now I'm going to minus 3/4, and that's going to mean that I have 1/4 left. So I'm going to put that right here because I have 1/4 left. And like I said, you could probably just use decimals on this one if you're totally stuck. But try using the fractions whenever you can, because that's something that bugs me a lot, especially if you're planning on going into a college course, because most college courses I taught are full of, you know, 19, 20-year-olds that can't do fractions, and it's just, I don't know. Fractions are just one of those things that we need to all learn. Okay, I don't care who you are, what you do, you know, especially if you're like a tradesperson, you know, framer, woodworker, carpenter, welders. You all need to learn how to use fractions. It's just something you're going to be using every day. Anyway, let's go ahead and I'm going to quickly do this. So again, it's just a middle number here, so it's going to be -1 and then x. And again, you can use your life method. -1 times -1 is +1. -1 plus -1 is -2, so it works out. Now, in this case here, I think we're ready, excuse me, to divide both, not divide, what am I talking? It does kind of look like a division bar though, but we're going to take the root of both sides. And in a way, it is kind of a division. It's like a specific branch of division. Anyway. And square root of a fraction. So remember, take the square root of the top number and then take the square root of the bottom number. Let's see, just let me go writing over here. So again, if you have a square root on a fraction, you just take the top and the bottom and you square them individually. So that's where I got 1/2 from. And we also have to have the plus and the minus here, so don't forget that. Okay, it's easy to forget that. And I'm also going to have to add 1 to both sides to get this by itself. And let's see what we can get. X. I wonder if I'm going to run out of space. I'm going to do it over here. So x equals 1 plus 1/2, and x equals 1 minus 1/2. Now, when you add 1, that's probably the easiest type of fraction you can do. Easiest type of fraction because any number over each other. Okay, so back to this one here. Why did I pick 4? Well, you can pick any number. You know, I could pick 5 over 5, but that's not going to help because I need the bottom numbers to match. I could pick 100 over 100 and it would still just be equal to 1. But since I want the bottom numbers to match, I'm going to go with 2. So 2 plus 1 is 3, and the bottom numbers do not change when you add or subtract fractions. And then same thing with here, 2 minus 1. So 2 minus 1 would be 1, and this would be 1/2. Now, with this case here, since I have a top number that's a little bit bigger, that would be like 1.5 or 1.5, which in this case, I can just go ahead and write that as 1.5. But since I want the smaller number to go first, I'm going to go ahead and put my smaller number first. So that would be 1 1/2. And you could leave it as 3 over 2, okay? If you're not sure how I did that, you can just leave it as 3 over 2, or like I said, if you're really, really stuck, go ahead and just use decimals. Hopefully you know how to use decimals because I know a lot of other teachers here let you do that, which is, again, probably why we have so many people graduating that don't know how to work with fractions. Okay. And that's it for this one here, so we are done. Let's go ahead and move on over to number 6. Now in this case here, it looks like we're going to have to move this out of here because remember, that's the first step. We got to make this look like that format that we were shown earlier. Leave a space. Well, in this case, I don't really quite need to leave a space now because I still got to get rid of this a value. Because when we're trying to complete the square, having an a value is going to be a really tough thing. And it looks like we're going to be left with a bunch of fractions. All right. All right, so what can we do with this fraction? Well, we still have to do the whole take it, half it, square it. So let's just get it over with. So take it as is, so that's 10 over 3, and we half it. Long story short, if we double the bottom number, that is essentially the same thing as halving it. Darn it, I'm out of space to write. You could also go something like this. So 10 over 3 divided by 2, right? And then if you want to divide it by 2, it'd be 10 over 3 times the reciprocal. So flip that over and you get something that looks like this. So that's why the top number stays 10. And 3 over 2 is 6. Sorry, 3 times 2 would be our bottom number, which is 6. So take it, half it, and we need to square it. So in this case, it would be 100 over 36. Now, that's not really needed here because we could just divide both of it. Let's see. Think of the largest number we could divide out of both of these numbers. We could go with I want to say 4. 100 divided by 4 is 25. And then 36 divided by 4 is 9. Okay. Ooh, oh, okay. So all I did was just simplify it there. So just simplify it. Plus 25 over 9. Plus 25 over 9. All right, now we got to use the division. So break it down using factoring. And again, it's always going to be this second step right here, the second step in the take it, half it, square it. So in this case here, it would be 10 over 6, but we can simplify that to 5 over 2. Now I'm also going to have to add these together. Negative 8 over 3. Now in this case, that's not going to work out. If you wanted to, now this is the reason why you need to learn how to work with fractions, because I always get students that will say something like, well, can't I always use decimal? And I'm going to show you this one so that way it's not mistakable. So the fraction was 8 over 3, which means 8 divided by 3. Well, how do you add a number like that? Well, you can't. You can't add a number like that because if I add a number like 2.6666 plus, oh, well, in this case here, I'd have to look at the other number, which was 25 divided by 9. That is also a repeating number. So no, you cannot always use decimal. Okay, you cannot just run to decimal every time things get bad. And if you round that off, you are losing a lot of value. And if you have to keep using that number over time, it's going to stack up. All those little errors are going to stack up and it's going to become an entirely different number at some point. And it probably won't even have to take that long. It could be as little as 1 or 2 steps. You will change the number's value. So anyway, that's why it's important to learn to work with fractions. And again, adding or subtracting fractions, you need the bottom number to match up. So this is a pretty simple fix. Times this by 3, you get 9. Times the top number by 3, so you have to multiply both of them by 3, because 3 over 3 is just the same number. So this would be negative 24. Now let's go ahead and subtract or add it in this case. Well, 9 over 9 is going to be 9. 25 minus 24 is going to be 1. Okay, not too bad. We have our new number. Let's go ahead and take the root of both sides. So take the root here, take the root here. X plus 5. Actually, I should write this a little bit over. Plus and minus 1 over, and then again, take the square root of both numbers, just like we did over here. Take the square root of 1, we get 1. Take the square root of 9, we get 3. And then from here, I'm going to have to minus 5/2 to both sides. So we have positive 1/3 minus 5/2. All right, so the question is, well, what do we do in this case now? Because we got to add them. So let's see. Don't want to erase anything, but I am going to need some space to write some of this out. Okay. I just used a different color. I'm going to, okay, so hopefully we got that part done with. So let's see, 1/3 minus 5/2. So I'm going to need to change this so that they both have the same bottom number, which is 6. Now I need to change the top number because I can't just leave it the same, because if you look at fractions, like a pi, right? If this is 1/3 of a pi, it's not the same thing as 1/6 of a pi. So they have to be the same thing, but different numbers. So double this number, double the top number. And then over here, same thing. How do I go from 2 to 6? Well, we times it by 3. So times the top number by 3 also. So this becomes 15. And then becomes 2 minus 15. Okay, where's that? Oh, there's the green color. Actually, hold on a minute. Is it 5/2 here? So wait, 5 over, divide that in half, divide that in half. Oh, okay, so it should be 5/3. Actually, this might make things a lot easier. That should be 3, which would mean that I'd be adding or minusing 5/3 to both sides. Okay, that's actually a lot easier because now I don't have to worry about any of this weird stuff here. Because I was thinking to myself, that's actually really difficult. I don't think they'd throw something this difficult at us right off. I think we're ready for the answer here. So 1 minus 5. What is 1 minus 5? That'd be negative 4/3. And then now we have to consider, what if it was a negative? So negative, so they're both negative. So -1, -5, that'd be -6. Which in this case, I can divide that. That would be 6 divided by 3 is 2. But don't forget that it's a negative, so that'd be -2. And normally I'd say, yeah, I wish I could do like a whole thing on fractions just so that way this is all a little bit less confusing, because I understand that this is definitely confusing. I really hope they don't have so many more to do with fractions, because yeah, they are kind of time consuming. Even though they're not really that tough, it still does take a little bit of work and effort to get there. All right, anyway, let's go ahead and get back to this one here. So same thing with this one here, number 7 is, let's go ahead and get rid of the 21 here. So add 21 to both sides. X squared plus 16x, and I don't have an a value, so I'm going to go ahead and just write this over here. So that'd be 21 minus 5. 21 minus 5 would be 16. Now we have to take our b value, so take it, half it, square it. So this means I'm going to have to add 64 here and add 64 here. Break this down into a square number. So let's see. And again, just take your 8, or in this case, 8 was our middle number. So just take that number here, plus x. 16 plus 64 is 80. And now I'm going to have to take the root of both sides. So I get x plus 8 equals positive and negative root 80. But I'm also going to have to break down 80 into some other numbers that I can work with. So we have root 80. And let's try to get the biggest square number that we can. All right, now I'm going to, well, if I ask students, okay, what numbers can I break down 80 into? Probably the first thing I'm going to get is 8 and 10, which neither of those are square numbers. So we want the biggest square number we could find. And there is kind of, well, I don't know if it's easier, but it's a different way to do it. But let's just stick with the ways that we've been doing this. So one thing we could do is try a different number. We could try to double one number and then half the other one. So let's go ahead and half this number so we get 4. So there was 8, we half it, we get 4, and then that means we'd have to double this number. 4 times 20 is 80. But hold on a minute, because 20 can also be broken into 4 and 5. And this is what I mean by check it to see if you can break it down any more. Which in this case here, yeah, 20 can be broken down again. So what I'm going to do is I'm going to take this 4 and multiply it to that 4. And what is that going to do? Well, we get 16. And that would be 16 times 5. Oh, wait, no, 16 times, let's see, what would that be? 16 times 5, is it? Yeah, it is. Okay, I don't know why. I must have pushed the wrong button on my calculator. But yeah, it should have been 16 times 5. And that's how you would get the larger number. So again, remember, these are 2 square root numbers. So we're going to take the square root of 16. That would be 4 root 5. Because there's nothing we can do with this 5, so it's just going to stay in there. And now I need to get rid of this 8. And it looks like we got negative 8 plus and minus square root of 4 root 5. And at this point, we cannot go any further. There is nothing else we can do. Again, we could put it into a weird decimal number, but that's not going to help because just writing it like this is going to be fine. And it's also going to be more accurate because I don't have to round anything off. Because if you remember, if you take the square root of a number that's not a square number, you're going to get a whole bunch of repeating decimals. And again, if you round it off, then it's not really accurate anymore. It's not really telling you what number it is. Okay, so looks like in this case, we're ready to move on to the next one. And I noticed that it's already in the right form, so I don't need to add or subtract anything on either side. So we're gonna go ahead and skip, I forget which step it was, but we're gonna go right over to the step where we divide everything by a. So x squared minus 10x. And I think I'm ready to put something here. So 69 divided by 3. That would be 23. All right, so let's go ahead and take the x, take it, half it, square it. So this means I'm going to have to add 25 to both sides. So plus 25 here, plus 25 there. And then we're ready to break this down into here. So again, look at your middle number, x minus 5 squared. And check it really quick. Negative 5 times negative 5 is 25, and negative 5 combined with another negative 5 is negative 10, so it works out pretty well. And then over here, I get 23 plus 25, which is 48. Take the root of both sides. That square is gone. And here I get root 48, and it looks like we're going to run into a similar problem that we did with this one, because we're going to have to break it down again. So 48. So think of two numbers that we could break down 48 into. And let's use a square number. So let's go with 4, because in this case 4 and 8 are both divisible by 4. So 48 divided by 4 is going to be 4 and 12. But look at 12, right? Because we have another combination. We have 2 and 6. But neither of those are square numbers. You could also try another combination like 4 and 3, which in this case, I have 2 square numbers. And then we pretty much get the same thing we did from here, because if I put these together, I get the square root of 16. Now there's the other way I was talking about is if you have a pair of them, you can just take that out, and that is your number. The whole number part of your irrational number. But in this case, let's stick with what we've been doing, and let's go with 16. What was it? 48 divided by 16. That was 3. Because remember, we're taking the square root of both of these numbers because it's the square root of 48. So plus and minus. But we can take the square root of 16. That would be 4 root 3. So we take that out. And now we still have to add 5 to both sides. X equals 5 plus and minus 4 root 3. There we go. So it looks like there is nothing else we can do in this case. So we are done with this one. All right. That one wasn't as bad as the one with the fractions. And it looks like we only have one more to go. So this will be the last one. And like I said, yeah, a good strong foundation in fractions would really help out with this. But it looks like it was only 2 problems. I'm hoping these ones don't have any. Again, even when you are good at them, it's still a bit of work. All right, excuse me. Let's go ahead and get this working. First thing we got to do is separate the regular numbers from the x numbers. X squared plus 12x. Now I can already kind of tell that we are going to have something happening. It's not fractions, which is good, but it is something different. And I can tell because we have a negative number on this side by itself. Well, what does that mean? Okay, you'll find out. So let's go ahead and find our new c value. So get the b value, take it, half it, square it. 6 times 6 is 36. Okay, so that means that I am going to have to put in 36 on both sides. So add 36. And that allows me to complete the square to a perfect square trinomial, which again is going to be my middle number. So it's going to be plus 6. X plus 6 squared. And again, 6 plus 6 is 12. 6 times 6 is 36. Let's see, 36 minus 43. That would be 7, negative 7. All right, gotta remember that's gonna be a negative number. Now, I hope we can take the square root of both sides, but you notice that we are taking the square root of a negative number. And this is gonna require another piece of information that we've covered before, and that is the square root of a negative number. So in this case, I'm going to pick -1 is going to be changed to the imaginary number I. So as I take the root of both sides, so plus and minus, I'm going to have to take I out of that group. I root 7. And that has the effect of taking the negative out, right? Because you cannot take the square root of a negative number, okay? You can't do that. So if I said a number like x squared equals, negative 49, well, what could I put in there for x that I could square it and get negative 49? Well, probably the first thing I'm going to get is 7. Well, 7 times 7 is positive 49. And then the next thing I'm going to get is negative 7. Well, -7 times -7 is going to be positive 49, not negative 49. So it's not going to work. And then they say, well, can't you use one negative and one positive? Yeah, but you can't do that because the definition of a square number is a number you times by itself. And if you have one of two different things, then they're not the same thing. So in other words, that's why we just say, okay, it's imaginary. We just take this I out, take the negative out, and it becomes I. Now we still have to keep working with it. And that's why, because sometimes I'll get the question from students, why can't we just say no solution or something like that? Or, something like that. And there's a bunch of different words we could use, but that's usually the most common one would be no solution. Why can't we just say no solution and be done with it? Well, because sometimes we need to keep working with these numbers. In this case here, we do need to keep working with it. And sometimes we need to put it back together. Or if you remember what I was telling you earlier, if we were to change a few things, if we were to maybe raise a value or two, we could make an imaginary solution into a real solution. In fact, you know what? I'm gonna get over to the internet and I am going to show you something. I'm gonna show you how you can change something from an imaginary number into a non-imaginary number. So I'm going to just make this up. So I got x squared, and that should give me a parabola. And I'm going to move a slider a. So in this case, a is equal to 1. And normally if a is equal to 0, that would just give us our basic parabola. All right, so this is just the parabola of x squared. Right now, there is one solution. If I were to drop this down, you would notice that I'd have two solutions, one here and one there. You can see that it contacts the x-axis twice. So that's how we have two solutions. That's the same thing. I'm just raising one value. So in this case, if I were to raise so this is x squared plus 2. Well, x squared plus 2 has no real solutions. But again, if I were to just lower one number, I could easily go back to having two solutions. And this parabola can move up and down. So that's why we don't say no solution, because when you say no solution, it means there can never be a solution. But there can be a solution. Okay, there can be a solution, and you can take real solutions and turn them into imaginary solutions, and you can take imaginary solutions and turn them into real solutions. So that's why we never just stop right there, because it's just as simple as moving your parabola up and down, and that's all you would need to do. So that's why we say imaginary. And I think I said I wasn't going to talk about that, and here I ended up talking about it. But I know I get those. I do get questions like that a lot, and even if people are not afraid to if people are afraid to ask them, I know that's still something on people's minds, always is. All right, so I'm gonna have to do two things, because in this case, to get my x numbers on the same side, I'm gonna have to do minus 16x, and I'm also gonna have to do this thing here. All right, so 4x squared minus 16x right here. And then this is canceled. So I'm gonna leave a space here, although I don't think I need to leave that space here. This is canceled here, so that's gonna leave me with only 76. Now I'm gonna do the take it, half it, square it with negative 16. So take it, half it, square it. So this means that I'm going to have to add 64. Oh, wait a minute, we're not done yet, because we have an a value. So be careful with that. There is an a value in this case. So this completing the square, now that's a good question. Does it work if I don't do that? I think it would. I think at some point it'll kind of balance itself out again. But let's follow the directions, okay? When in doubt, follow the directions. Again, I'm pretty sure it'll work out even if you were to skip that step. but you'd still have to simplify it to lowest terms and all that stuff. Anyway, so let's go ahead and now we take our new b value. So take it, half it, square it. So by squaring -2, we get +4. So that means I'm going to have to add 4 to both sides. Oh, shoot, I almost forgot the negative right here. Looking at that a little bit closer, that would have been bad. I think I already made a mistake or two today already. You don't need more. So that's also something that commonly happens. These negatives just sort of drop off. All right, so two numbers that multiply to +4, but we'll add to -4. So -2 times -2 is +4. -2 plus -2 is also going to be -4. So that it works out for both of those. So here I have 4 minus 19, and that would be -15. And it looks like we have another negative on the opposite side, which means we are going to have an imaginary number. And that's usually one of the big things that happens. So if you see a negative root or something that will become a negative root, that's usually a sign that you are going to have imaginary solutions, or what we can call no real solution. Because if you remember that big chart we covered in the last class, there was like real numbers, and then you had complex numbers on the outside box of that. All right, so -15. I don't think there's anything we can do with 15, right? Because it's only 3 and 5, and neither of those are square numbers. So I think we're just gonna have to leave it in there. But we can take this I out, and that has the effect of removing the negative. So now we get around that rule of having negatives in the radical by just taking it out and replacing it with I. And again, this helps us to keep working with the problem so we don't have to just stop, okay? And I think in this case here, we're going to end up with a complex solution again. So x equals 2, because now this 2 is always positive. I think I missed a little bit of that, and you might have already known that, but I do also get this question from time to time, and that is it always going to be a plus? Well, not really, because sometimes it can be a -2. Like in this example, our real portion of the number is negative. But in this case, it's positive because we plussed both sides. So it's always going to be +2. The plus and the minus belong to the x. I'm sorry, in this case, the I. So it belongs on the I. So however we write this, that plus and minus always has to go with the right term, which in this case is the I. Whew. Okay, there we go. So that is it for this entire thing, because the next one is blank. So yeah, okay. I guess this wasn't so bad aside from the fractions one. I think not so bad. All right, so we've covered imaginary numbers, we've covered irrational numbers, we've covered, you know, the real number system, which I think were the first two, which I think they were like questions 3 and 4. You know, those are just like real number solutions. So it looks like they're kind of put in pairs, because here we have complex numbers as solutions. Here we have irrational numbers as solutions. Here we have fractions as solutions, which again, I really hope people really brush up on their fractions. And I know people don't like fractions because of calculators and stuff. And here we have real number solutions. Yeah, it was 3 and 4. So I guess they're kind of grouped in a way that, you know, you get different answer types with them. Anyway, so that is it for today. I think I don't have much more to go over. So I think we're going to go ahead and be done with this week. So that will be it for today, and I will see you next time. And we only have 3 more weeks. So actually, I put in the packets, 2 packets. And one of the packets has 3 lessons. And then the last final week, I think ends on Thursday. And that would be the final exam, which there are 3 final exams, they all count as, it's all one score, but the 3 final exams count as your attendance for the last week. So Tuesday, Wednesday, and Thursday, if I remember correctly. I'll go ahead and make an, I'll make an amendment to that if I remember, but I'm pretty sure that's what it is though. So that,
Okay.
that's one lesson. So it should be enough for all the rest of the thing. Anyway, that's it for today. So it's you have everything you need in the final packet. All right, bye-bye.
Okay, bye.